Hi, my name is Dr.
Gaukhar Baidildinova.
This video is a part of my lectures on evidence-based medicine and epidemiology. What is the H-index? The H-index is a measure of individual citations, essentially a recognition of research. It serves as a sort of rating for a scientist's output and impact. The index was proposed by George Hirsch in August 2005. H-index is the smallest number between a number of publications and a number of citations. For example, if you have one article cited 100 times, your H-index is 1. If you have 100 articles each cited only once, the H-index will be also 1. If all 100 of your articles are cited 100 times, your H-index will be 100. The H-index can be looked up on websites like Scopus, Web of Science, and Google Scholar. How exactly to do this? I will link a video in the description box. H-index discrepancies. Because each database counts citations in different ways, the H-index can differ significantly across platforms. For example, Google Scholar might show a higher H-index compared to WOS or Scopus, simply because it includes citations from more diverse sources. If you want to compare researchers, it's crucial to use the same database to track their H-index. H-index is criticized to be subjective, and there are several moments important to realize when we discuss this metric. Fashion in science researchers working in highly popular or mainstream fields tend to have higher H-indexes than those in more niche areas. For instance, biomedicine and IT, especially with artificial intelligence, are currently the most relevant fields. In contrast, fields like geology and archaeology are of less interest to the general public. These areas often have fewer projects, less funding, fewer specialists, and, consequently, fewer publications and citations. Therefore, it is incorrect to compare the H-indexes of researchers from different disciplines without considering these factors. The H-index and research disciplines. In biomedical research, the first author is typically a biologist or medical scientist who invests weeks, months, and sometimes years conducting experiments and clinical studies. A biology article, for example, is rarely published in the first year of research. On the other hand, statisticians or epidemiologists can compute results much faster, often within hours or days, which leads to more publications where they are credited as authors. If you compare fields like biology, chemistry, and physics, you'll find that chemical and physical research tends to progress more quickly, resulting in more publications over shorter periods. Age of the researcher. There is a clear correlation between a researcher's age and their H-index. The older a researcher is, the more likely they are to have accumulated a larger number of citations over time. This makes it difficult to compare researchers at different stages of their careers. For instance, comparing a near 30-year-old doctoral student with a 50-year-old professor might not be meaningful. Even comparisons between researchers at similar career stages can be misleading, especially for the young postdocs just starting out. The reality is, it is rare for a newly minted PhD to independently decide on their career path. Early scientific achievements are often influenced by the reputation of the research group or the institution. For example, on the 5th year of my doctoral studies at Johannes Gutenberg University Mainz, I had 4 publications. However, it's unlikely I would have been as productive if I had conducted my PhD at my alma mater in Almaty. The importance of a research leader. A good leader will make all the difference. I also have 2 paid courses on Udemy. The Critical Assessment of Clinical Studies teaches how to read and critically evaluate clinical studies. It's a very great course. The same as my second course, Scientific Writing, where I tell all the nuances of how to write a scientific article or dissertation. Links are in the description box. Authorship practices. Different research groups may have varying rules for awarding authorship. We know that to be credited as an author, you must make a significant intellectual contribution, but this is not always the case. In some labs, technicians who conduct experiments may be listed as co-authors, while in others, their work might be considered purely technical and not qualifying for authorship. Interestingly, there's a physics publication that includes over 5,000 authors. But when it comes to the H-index, it doesn't distinguish between different types of authorship. Whether you're the first author who contributed 90% of the work or the 7th, 20th, etc., you are equally credited for citations of that joint publication. Breakthrough impact and neglect. One key issue is the neglect of breakthrough discoveries. Researcher A, who has published a groundbreaking discovery that is widely cited, may be given less respect than researcher B, who publishes frequently but has not contributed to any major breakthroughs. This is similar to comparing one-hit wonders in the music industry. While on the other you have those with decades-long careers and numerous songs, but no single iconic hit. Can we really say that their contribution is less significant than that of the creators of Macarena or Gangnam Style? For example, Dr. Piotr Chomczynski, who developed a method for RNA isolation, has over 65,000 citations, with 93% of them coming from his 1987 article on RNA isolation. Yet, his H-index is 23, which seems low considering the impact of his discovery. One of the articles I used for this material even references our socialist past in post-Soviet countries, how a car factory might proudly announce the production of its 1 millionth car, despite the fact that many of these cars barely run or break down quickly. Final thoughts. The H-index is a useful metric for tracking a researcher's citations, but it's far from perfect. It doesn't account for breakthroughs, the quality of work, or the actual intellectual contributions made. The H-index is influenced by various factors, including field of research, age, and even institutional reputation, making it difficult to compare researchers accurately. What would be your opinion? What would be a better replacement for H-index?